welcome to Stream 2. I'm Maria Rosa Re, and I'm a researcher fellow at the Department of Education of Roma Tre University in Italy. I'm here to welcome you and introduce you to the session. The Learning Ideas Conference brings together researchers and practitioners from around the world to discuss, innovate and create. So it's a place where the international community gathers to find new paths, solutions and innovations in learning and technology for the workplace and higher education. Today's session name is Stream 2, and I'm so happy to kick it off to the first presenters of this session, Dr. Reiner Hutwelker, from the Technical University of Munich, the Institute for Lifelong Learning in Germany, and Professor Holly Ott, Rosenheim University of Applied Sciences from Munich, Germany. And I kindly ask to Dr. Reiner Hutwelker to share his screen. The presentation title is a Lean Six Sigma Certification Mooc, Balancing Standard Materials and Individual Guidance to help participants implement real projects. Dr. Reiner Hutwelker, Six Sigma Master Black Belt and formerly with Siemens Management Consulting, is today an independent business consultant and a senior lecturer at the Technical University of Munich, with more than 25 years of experience managing and implementing Six Sigma and Lean process improvement projects, both in production and in service. We are using the Q&A box for questions and the chat for technical issues, so please post your question in the Q&A box and we will respond to them at the end of the presentation. I'd like to remind you that the presentation will last about 45 minutes or 50 minutes, and we'll have 10 minutes for more questions. So please, Dr. Reiner Hutwelker, please start your presentation.
Maria Miranda, can you see my screen?
Yes, perfectly. Yes,
Great,
perfect.
thank you. So, Maria Miranda, it's my sincere pleasure and a big honor to be with you and your audience today. Thank you very much for having me. And as you already mentioned, this is a contribution from Professor Dr. Holly Ott and from me. And to give you just a short overview, you also mentioned my background. I'm a psychologist and I'm a Six Sigma Master Black Belt. Started my professional career at Siemens as a developer for user interfaces, for hardware and software, and then switched to the management consulting for Lean and Six Sigma. Actually, I'm an independent business consultant for 25 years now, with experience in production and service, and I'm a senior lecturer at Technical University of Munich at the Institute of Lifelong Learning. This is the content of my presentation. So we will start with an introduction to Lean Six Sigma, and I will introduce our chef, our little chef de cookie. Then I will present you some facts about our Lean Six Sigma MOOCs. And the core of this presentation will be about the development of our MOOCs and our trade-off in the balance of standardized and individual guidance of learners. And the same is true for not only for the development of our MOOCs, but also for the operation of our MOOCs, also here balancing standardized and individual guidance. And finally, I hope there will be some questions from you, and I hope that we will have a nice discussion there. So to introduce Six Sigma, you should know that Six Sigma is a concept with three meanings. First of all, it's a management system to increase customer satisfaction and to reduce cost in business processes. And for this purpose, companies educate about 5 to 10% of their employees as Six Sigma yellow belts, as Six Sigma green belts, and black belts. And hopefully this company also has some kind of improvement system with a continuous flow of improvement topics. And these topics are then evaluated and selected and implemented as Six Sigma projects, and for the new candidates also as certification projects. The second meaning of Six Sigma is its performance level. So if we talk about Six Sigma, there is also, of course, 5 Sigma and 4.3 Sigma. So it's like a grade in a school, which indicates the performance of a certain process. But it's a little bit more in statistics. So it's also about descriptive and inferential statistics. And finally, what we want to do and what we do is a data-based root cause analysis of problems. So Six Sigma is basically about a scientifically driven problem solving. And we do this with a certain method, which consists of a set of 5 phases. This method, the DMAIC phases, define, measure, analyze, improve, and control. And there are a set of tools within these phases. And we tried and we implemented several practical principles and a scientific approach to this method, and which is suitable basically for any business process, but we also extended the view. All of these perspectives, all of these meanings are intended to improve operational excellence. The focus of our Moocs is on the statistics and is on the method of Six Sigma, not so much on the management system itself. So if you remember Lean and Six Sigma management systems to improve business processes in production and service, let me give you some examples of certification projects in the past that might indicate the variety and the relevance of Six Sigma projects. This is a classical example. We had pinholes and cracks in laminate material of blister packs, and this was implemented in production, and Six Sigma originated in production at Motorola and was developed in 1987. Another type of project is, this is an example for a service project here. It's about the delayed publication, wrong prices, and translation errors in an online shop. Another example focused on the development is about wrong dimensions in technical drawings for deep supply units. And we then generalize the approach for any repeated process to also offer certification projects, not only to employees, but also to students and job seekers. And this is a project actually running in Lagos in Nigeria about blocked sewers and resulting flooding in a city center. Let me now please introduce our Lean Six Sigma project scenario. And this is one scenario which is where we developed a complete project, and this is the start and the basis, the anchor for all of our students. And the task is to transfer the ideas of this scenario to their own project. And in the first step, it's important that the problem within a process is identified, because problems in Six Sigma are the anchor, the start for any project. And if you like, then you can participate when I show this video, and maybe you would like to draw a list and list all the problems that you observe in this video. You will see this in double speed. Typically, in a normal speed, it takes 5 minutes. So it will take 2.5 minutes for us.
Hi, I'm Laura. I'm procurement, logistics, and production service, and I take care that the kitchen doesn't burn down.
I'm safe. What's my name?
First day is what?
Gemandelte.
Gemandelte?
Gemandelte Eier holen. Jetzt aber. Jetzt. So lecker.
Ja? Genau, so nochmal. Die Hände sauber. Oh, nee.
Da war ein Gerüststück.
Hey, the cookies are here. Happy birthday. You are 1 week early. Oh, bleh.
So the first task for our students is now to, let me switch back to the slides here. So the first task is for our students is to identify the problems. And I prepared this already for you. So we primarily anchor problems in the outputs of our processes. And this can be final outputs, and this can be also intermediate outputs. So what you might have observed is that the cookie taste is bad. And you might also have observed that the cookie delivery was 1 week early. This was probably a little bit difficult to understand, but this was about the delivery and the early delivery. You could also see that the cookie diameter was larger than the tin. So here already a little bit more specified, cookie diameter larger than 10 centimeters. You could also observe that there was a waste of ingredients, which we can directly relate also to the cookies. And you could see that there was a waste of energy, the high degree of how they preheated the oven. And what you now might have already observed is that there is a certain structure how we formalize the problems. The first thing is, and the first task is to focus on the right object. And this is the final product here, so it's all about the cookies. The second part here in this table is about attributes. So basically what we see and the source of variation is not the object itself, but these are always attributes. And here we can discriminate the taste, the diameter, the delivery, ingredients, energy. And now here, the third part of this description of this scheme is the deviation. So here we can only say cookie tastes bad. It's not very precise yet. We can be a little bit more precise here with the cookie diameter being more than 10 centimeters and so on. So what we require here, and this is a quite a big requirement, that participants first find out the correct objects. And this can be, of course, a cookie. And this can but also be teaching a video of our course material. And this can also be an immaterial object like a decision or an answer, for example, in a call center. And these objects, cookie, video, decision, they are characterized by lots of attributes. And here, for example, the taste is important. For the videos, for our learning material, the audience retention is important. And for a decision, the content may be important. And the deviation here for the cookie tastes bad, we have the video audience retention may be discontinued, and the decision content may be a false alarm. This structure is very important for us to have a very early idea already in the early phase of the project to see whether we would be later able to measure our problems. We can further classify these objects, these problems to 3 categories: to quality, to the availability and consumption, so the cookie taste and the cookie diameter. These are aspects of quality. The delivery is about availability, and the ingredients waste and energy waste, this is about consumption of inputs and resources. Then we need to discriminate in the beginning what causes or what negative influences you might also have observed. And here you might have seen that we had an order, and the order specification on taste of the cookies was quite ambiguous. The cookies should taste like those of grandma. So this might be a negative influence on the taste of our cookies. And you could see that the ingredients were determined individually, and this is also a source of variability which could affect the taste of our cookies. You also, of course, observed that our little chef nibbled chocolate from the ingredients several times, and that she manipulated the timer setup, and that the cookies were shaped variably, and that the date on the calendar was wrong, and that the oven was extremely preheated. So here we assign and classify these negative influences in a process model. So we assign the order to the input, of course. To the input, we would assign a recipe, or this individually determining the ingredients, to the methods, how we do the things. We discriminate resources like our chef herself, like the timer, the oven, and we have certain activities which we cannot directly assign to one of these resources or methods. This is, for example, the nibbling of the chocolate. The next part can show you already the first picture, or a kind of a twin of the problem and of the complete situation, which gives you a clear structure about the causal relationships. So the first step will be to identify the problem. So here we have the problems again. The cookie tastes bad, the delivery is 1 week early, and so on. We have the triggering causes of the order specification, the ambiguous order specification, the ingredients individually determined, and we have effects of the problems. And this is very important to discriminate problems from their effects. And the effect of the bad taste, for example, is that the customer is dissatisfied. Another effect could be that the customer claims for compensation. And of course, there are costs of the company for the wasted ingredients, and they overall lead to revenue losses of the company. And to complete the picture, you see here already some ideas we have on the solution. So ingredients individually determined, maybe we use cookie blanks, or we forbid nibbling, and we determine the correct oven temperature. This discrimination between these components to discriminate problems from their causes, from their effects, and from their solutions is very often, and most of us are not very good. At least this is one of my experiences. What you see here is the result from a newly hired CFO in a quite big company. And he asked for problems in the different sites he visited of the company, and he got 211 responses. So he asked for problems and got responses, and 76% of these 211 responses were about solutions. So you ask someone for a problem and you get an idea for a solution. 11% were about causes. 3% were problems, the class that he asked for. 1% was about effects, and 10% was not defined at all. And you might experience this also in everyday life. If you talk to your colleagues, what you hear also in the news, you get similar results if you ask, what is the problem, for example, of the COVID pandemic? You will get lots of different answers what the problem is. So this basic tree, this first structure of a problem, cause, effect, solution twin will further be specified and statistically analyzed within the project to find then solutions for the important root causes. This is the basic idea of Six Sigma. Let me give you some facts about our Moocs before we come to the core. So we offer 3 courses for Yellow Belt certification on edX. They all together, the first one about define and measure, about the DMAC method, the second one about analyze, improve, control, also the DMAC method, and the third one about lean production. They all together lead to an edX verified certificate and to the Lean Six Sigma Yellow Belt certificate. And additionally, we offer in the 4th course the Greenbelt certification project. And there are 3 different paths. There is the classical path for individual business projects for companies. So this is aimed at employees at companies. But as you might remember, we widened the scope. So we additionally offer a predefined community project about environmental littering in the respective hometown of the participant. And this project is follows the United Nations Sustainable Development Goals number 11. And the third project type we offer is an award project for an outstanding project idea, also following one of these Sustainable Development Goals. And this is directed to anyone who is interested. New for us, or new on the market, is thus that we now have a complete online business projects for companies. So this is the traditional way, now completely online. We have, with our predefined community project, we have a new target group and we have a new application area. And for the award project, we also have a new target group, a new application area, and this is free of charge. So all these three paths lead to our Lean Six Sigma Greenbelt certification. Some facts about before we make this deep dive. So we have the first three courses for the Yellow Belt. They are completely held online, and the Greenbelt certification project is online, supported online. We have additional lectures once a week. We have additional coaching, and we have reviews of the project in these 5 phases of the DMIC method. We have these 3 paths for individual business projects made up of lectures, individual coaching and reviews. Our predefined community project for the students, there is no individual coaching necessary. So here we have the lectures and the reviews, and the award project is already very individual. So here we need lectures plus group coaching and reviews. To see how big the market and the interest in Six Sigma is, let me show you some data from Google Trends. These are data from the last year, and the blue lines on the right side show that the keyword Six Sigma training is more often searched for than Scrum. Scrum is actually also very prominent and very, very popular, part of the agile methods. And if the blue line is on the left side, there was a time where people around the world searched more frequently for Scrum training. So there's a difference. Six Sigma is still a little bit more popular, and maybe this comparison might help you to get an idea about the popularity of Six Sigma in the world. We published the Yellow Belt in 2015 and the Green Belt last year in 2020. Actually, we have about 300,000 participants with an average age of 29 years. 50% of them are in the age of 26 to 40, and we have 15% who are older than 41 years. We have 28 female participants and 72 male participants. 57 have a university degree, overall from 120 countries, primarily from India, then the United States and Germany. We also have a quite nice resonance. 2 of our Moocs, 2 of our 4 Moocs are highest ranked in the class central business courses based on 125,000 feedbacks on the courses, and all of our 4 Six Sigma Moocs are highest rated in the class central Six Sigma courses. This is our course team, Professor Ott, Professor Martin Grunow, and Tina Kumpuli from our management team. We have guest lecturers from 3M, ASQ, Infineon, Intel, and the Lean Network Institute. So let's dive in what this is about and tell you a little bit more about the development of our Moocs. And Moocs are, of course, also processes. The development of a Mooc is a process, and also the operation of the Mooc is a process. And Six Sigma and Lean are aimed to improve processes. So it seems natural to apply Six Sigma to the development of a Six Sigma Mooc and also to the operation of a Six Sigma Mooc. And the conflict we experience here was to find the balance between standardized material that we offer and the individual guidance that is still necessary. Let me show you one of the first tools of Six Sigma. This is a Carnot chart, and the Carnot chart shows six selected challenges and problems from us, challenges for the development and problems in the operation of our Moocs. The underlying Kano model helps us to prioritize the requirements, and we did it in the define phase, so in the first phase of the development and in the operation by expert assessment. So there are no data behind, these are just expert assessments according to the importance of a requirement. And there are three different types of requirements. There are must-be's, there is more or less is better, and there are delighter. And here you can see the different characteristics for these requirements. So this is the characteristic for a must-be. And it was a must-be for us that the teaching objectives we have are conform, more than 99% conform to the American Society of Quality and to the International Society for Six Sigma Professionals. So this is a must-be that we needed, that we wanted and needed to fulfill, that to assure that our certifications will be accepted worldwide. Why is this a must-be? So here you can see a must-be is a requirement that where the reaction of the customer, of the learner, or more general, the stakeholder, is indifferent. This is a requirement that the customer just requires as given. So as you expect that you can make phone calls with your phone. It changes you will perceive an immediate problem if you do not fill the requirement. So if you can make calls with your phone, the customer will be indifferent. But if the calls are broken within 50% of the time, then the customer will be, of course, angry. So here, this is how you can discriminate this must-be characteristic from, for example, the more is better characteristic. So this says the more you give from this, and sometimes the less you give from this and have from this, the more satisfied is the customer. From being angry if you do not fulfill this, up to complete satisfaction and excitement if you completely fulfill this. And we have these three requirements on a must-be level also for the development. So we wanted more than 90% of our teaching objectives illustrated by scenarios. The third one was a must-be again, which I will introduce. We wanted that the concept, how we conduct and support the project, has an application validity of more than 95%. So if a student identifies a basically suitable topic for Six Sigma, then we wanted to assure that our concept can lead him to a successful implementation and also evaluation of the project. This is also a must-be. The number 4, the requirement, the challenge we had, is also oriented to the development of our course, and it says that the tools that we provide should give the learner a guidance through the project in more than 80% of the steps. And here more is better, so the more we can guide the student, the better for the student. The 5th requirement we have is about the project support effort. So you saw that we have the courses, we have the material online, but we also have online lectures, and we need sometimes, of course, additionally support participants individually. But we want to keep the effort, the individual effort, low for our standard project, for our students, and it would be a problem for us if our support or effort per participant is larger than 1 hour. And the final requirement that I will talk about here is about our general support effort from our management team, about inquiries that are we additionally receive to our course. Let's start with the second requirement. Teaching objectives should have an illustration by scenarios in more than 90%. So this is a picture, an extract from our yellow belt, and overall the yellow belt is structured in about 30 hours of video lectures. We have interactive statistical exercises. We have interactive case studies and mini projects, and these were developed in cooperation with German companies. And as you can see here, this is a manufacturer of hiking shoes. And so they get an insight also students in industry and in different scenarios of industry. Overall, there are about 500 practices and homework problems, and this is the basics material for our yellow belt. This is completely held online. The additional green belt for the implementation of the project is structured in one consistent example project, which you already saw. This is our Cookie to Chef, 5 minutes, very short. We have about 6 hours of video lectures. We have a book with the same content, mirroring the content of the videos. We have a software, which I will give you a short demonstration, a guiding software, a project storybook template where the students need to document their project. And there are about 60 tasks to get these projects identified, evaluated, implemented, and evaluated. So with the yellow belt, we address the competence levels to remember, understand, and apply, and complete this by the competence levels of apply, analyze, evaluate, and create. Let's switch to the second requirement, or the third one, the second that I want to show here. We wanted that the project concept, the underlying concept, has an application validity of more than 95%, not only to the business processes, but also to these community processes. And the challenge here was to manage the balance, the trade-off between the valid application for a wide range of projects. So it's a topic about generality, and to have additionally a reliable and standardized guidance in each project phase, which represents the power of our concept. And overall, we want to assure to minimize our support efforts for projects. And we did this by adapting the DMAIC method to scientific principles. And this is shown here. What we want from our students is to differentiate their observations of the reality. So we have these 3 components: the observations of reality, we have the model behind where the observations should be mapped, we have the statistics, and these 3 components, reality, model, and statistics, are related by assumptions. So we draw assumptions from reality and integrate them into our model. So you observed our cookies, and you see here there's a difference between these cookies in 2 attributes. So they differ in size and they differ in color. And this is what we want, that students focus not only on the correct and the right object for the project, the right outputs, but also that they are able to discriminate the attributes, and of course then later evaluate the most important attributes. We also want that they think about relationships between influences in the process. For example, the timer here, the timer setup, the relationship between the timer setup and the attributes of our outputs. Then they need to translate their assumptions into the model. So we're talking about inputs into the process. This is the chocolate and the eggs we receive. We have a method like the recipe. We have resources like our chef and the oven. We have certain activities where the work is done, where the value is created. And we have, of course, outputs and intermediate outputs like the shopping list. We have a dough, we have the cookies raw, the cookies baked, and finally the cookies delivered. So we have certain stages of intermediate outputs, all related to certain influences in this model. And the integration then to the DMIC is that we also integrated the problem-solving perspective here. So problems are always, we simply define, problems are always related to outputs, and the causes are related to the method, to the activity, to the resources, and to the input. So this is an important circle and an important requirement and the most important transfer step to go from our cookie example and to map the observations from their specific project into this model. Then translate the assumptions in corresponding statistical hypotheses to collect data, to test these hypotheses, and to confirm the assumption or to reject these assumptions. So what we want is that the students not only implement just one specific project, but get some general competence to translate qualitative observations in quantitative descriptions, and finally in causal explanations. We needed, of course, it was necessary to transfer this project concept in specific guidance. So here we have the fourth requirement we have, our tools that we developed, and we wanted to assure that these tools can guide more than 80 steps, more than 80% of the steps of the student. This poster here shows all the tools the students need to apply, and they all have a certain structure. So these tools are all linked in a seamless input, activity, and output chain. And I will show you the project topic in just a minute. So this is how it works. We see you would first enter an observed weakness, like you observed in our cookie scenario, and there are certain weaknesses there. Then your task would be to describe the weakness, to identify a first draft of the cause and the problem, evaluate the risk, and then the output that is generated from the tool, it gives you a summary, some interpretations and recommendations on the inputs you made into the tool, and there are some data from this project topic extracted, and these data from the project topic extracted are then transferred to the next tool, to the project definition. So this next tool is based on these data already developed, and there are again activities and again an output and so on. So this leads to this seamless input activity output chain. Let me call this, name this a kind of macro guidance along these tools, and within the tools we have some kind of micro guidance. So most of the tools have a hierarchical information collection structure via a controlled dialogue for each tool. How does this work? The tool asks a question and you enter an answer. And then the next question is built up and is specified. The second question then is specified by a part or by the answer you have already given to the first question. And then you give an answer to the second question. And again, your answer is integrated in the third question and you give a new answer and so on. And finally, you will get a summary and you can check this, or the student should check this, and you will probably and hopefully see that there might be sometimes nonsense as an input. So getting these summary and this check would allow the student to go back and adapt some of these entries to follow this formalization and schematization and parameterization that we apply. So I would like to give you a short demonstration how this works. So this is Sigma Guide, and let me show you the first tool, this project topic again. And this is directed to all employees of a company, typically without any previous knowledge on Six Sigma. So there are 7 questions overall. And the first question is to describe, simply to describe the weakness of the observed weakness of the process, and maybe a weakness in the output, and describe the observations in some statements and answering the questions here. Which weakness did you observe? What are its causes? So these are assumptions derived from the first observations, and what are the consequences? And oops, this is, I already prepared here so that I do not need to enter the text here. So what you see here, bakery cookie dough chef has several problems. Most important, sometimes cookie tastes bad. Sometimes the cookies are delivered too early. Additionally, there is some waste of ingredients and energy. Well, now then the second question comes up, and what we require here is an answer to 2 half sentences, which should make a complete sentence overall. So let's have a look at the first one. Orders or tasks we receive decrease the quality of our products or services. It could also be that orders or tasks we receive decrease the availability of our products or increase the waste. So let's think about the orders that we receive. This ambiguous order in the beginning of the cookie. This might be the most important problem we saw. And you can see already here the first output here, a structure, a feedback. Orders or tasks we receive decrease the quality of products and services. Now this content is integrated in the third question. Which tasks or orders do you mean? So if we take, for example, the material, other inputs we receive, or if it's about the method, the instructions, procedures, algorithms, so the methods that guide our activities, like the recipe, is assumed to be a cause for a decrease of quality, or the machines, the equipment, and other resources, or simply the activity. Then the third question immediately changes, which activity do you mean? So let's switch to the order. We assume it's about the order, and the order decreases the quality of our products and services as one of our primary products. And then we are asked to specify this with which specific task or order do you mean? And this is our order for birthday. And which specific product or service is affected. And in our scenario, this is, of course, of our cookies. Now we ask about data collection, because this is important that also in the beginning we get some ideas whether we would later also get here the idea whether a data collection later would be possible. Can you basically collect individual data on each incoming order? And maybe we say, yes, we can. And can you basically collect individual data on each resulting cookie? And maybe also, yes, to make it simple. Then we will have what I would like to show here. We get also a kind of interpretation of this. Individual data can be collected on the cause, order birthday, and on the problem cookie. This measurement condition is typical for Six Sigma projects. So if we say, for example, we can collect data on the input, but not on the output, we would get some information. Please check again, because this is an unusual situation that we can collect data on inputs, but not on the outputs. And there's some recommendation what to do. And then let me do this quite quick. How frequently does the cause occur? How frequently can the quality defect can be detected at the place where it occurs? How severe is the problem, the effect of the problem on the costs of the company? How severe is the effect on the irritation of internal, external customer? And finally, estimate the minimum and maximum expected performance improvement and estimate the share your own department can contribute. And this then leads to the documentation, and we come to the relevance and summary and relevance and suitability of the project topic, where we have not only the summary, but also some recommendations about our project. This guidance is then continued from the first tool to the second tool, and this is what we basically do and how we want to assure the guidance of our participants. Let me show you just one more important part that you might be interested in. So one important part for the operation of our Mooc is that we want to keep the effort per individual student for our standardized project below 1 hour. And we asked our students, sometimes we make some ad hoc service in our Facebook group, and we had a question here, what our students prefer, an excellent book over a boring video, and this is preferred by 71% of the students, in opposite to the symmetric question, preferring a boring video over an excellent book. What we saw sometimes, what we see in the project documentations is that there are sometimes continuously, repeatedly errors students make. And this is very plausible because this modeling and formalization, although we give this guidance in the tool, and the parameterization of our guidance really requires the careful study and the application of the course material. And so we wanted to see how the participants handle our videos and how they handle our related book. And errors they have will, of course, errors they make will of course have a direct impact on our support effort and on the project success. To control this and to monitor this, we use control charts. And these control charts are also part of Six Sigma. And what you see here are the data of one of our course videos, and this reflects the audience retention. This data is publicly available. If you publish these in YouTube, you will get the data, download it, and you can apply the appropriate tools. So what we want here is to detect causes in our videos and our scripts of errors by detecting signals of the watch behavior of our students. And these control charts can give you some clues for the improvement by automatically detecting signals, for example, that students exit at start. So here is the amount of 100% of the students who joined the video in the beginning. And this is the decreasing performance over the video, also shown in 0 to 100%. So this is not in minutes, this is a complete video from 100% who started to the final students who watch the videos to its end. And what you can see here, some students have a repeated entry. So here the audience retentions in the beginning is larger than 100%. You can see intervals below average watch time. So this is the part here. We have the average here, and we have the average watch time here, and we have a large portion of this video below average watch time. We have certain outliers here and here at significant places. We have shifts in watch time, which is indicated by these dots here. So why does the watch behavior is increased, and why do students enter again? We have overall trends going down in this video, and we see what we also saw very often see, students again enter at the end of the video. So to summarize this, what we want is to get indications from the watch behavior of our students. If we experience errors in the performance of the students, try to trace them back to our course material and, of course, to improve our course material, to reduce our effort. So I think the time is over. Would be just one slide, but this is not so important. Maria Miranda, I'm open for questions now.
Yes, thank you very much, Dr. Reiner Hutwelker, for your presentation, for your thought-provoking presentation. I have personally a lot of questions for you, but just maybe I also invite all the participants to insert their question in the Q&A box. So thank you very much. I will start with my question for you.
Yes, please.
I'm so much impressed about the structure and the design of the Six Sigma courses, especially thinking about critical thinking promotion. I linked this idea thanks also to Deborah Owe's presentation, the keynote speech that we had before. This design that you and your team created in your Six Sigma courses are so much close to critical thinking development, thanks also to the problem-based design approach. So can you please explain us the relation between the Six Sigma courses and transverse skills improvement?
And to what?
Transversal skills, critical thinking, in particular, promotion.
So I'm not sure whether I really can do this, but it's basically what we want. The key for our students is some generalized or generic knowledge and generic competence. This is very important for generalizing this approach to also other projects. And for me, I worked as a psychologist. I'm a natural scientist, and I think this is very important to be able to discriminate. So this is one of the basic competencies, I think a basic indicator of intelligence at all, to be able to discriminate. And then not only to be able to discriminate, but also to focus on certain attributes. What we want is that our students can focus on a certain object and that they can list and immediately see these and these are attributes. These are the attributes that make objects. So if you think basically an object, what we see as an object, a bicycle or a cookie, is nothing more as a spatio-temporal coincidence of attributes. So we have a taste, we have a texture, we have a shape, we have a weight. So anything we can observe can be broken down in attributes. And this is what we want to strengthen, that our students open their eyes and go around and see differences and are able to discriminate things. This is the first, and the second one is then that they also are able to make assumptions about relationships. This affects that. So if we turn the setup of our timer, then the attributes of our cookies change. And not only for the cookies, but also for everyday life. So I'm sorry that I cannot relate this to certain topics you mentioned, but maybe this is
related. It's perfectly related, though. The idea to develop cognitive skills, and to think about how to use this kind of thinking methods in a very general and different context. So it's completely close to critical thinking. You mentioned, for example, relevance in your topic as an indicators of the activity students do in their courses. So I think it's so close with critical thinking and also with the main topic of our conference. So thank you very much. And another question for you is, can you deeply explain us the evaluation methods that are used in the Six Sigma Mooc because, for example, you share with us open-ended question related at the beginning of the session in the Mooc, and closed questions. So how these data are used by you and your team in order to evaluate and monitor the learning path for the participants in the Mooc.
So very great questions. So the first important thing, this was more an impression. We started the certification project, implementing of the project 1 year ago. And I was not quite sure whether the material we offered would be suitable to work as a standalone, so that students would be able to implement only the project only based on the videos and on the tasks and on the tool. And luckily, the first projects we received were completely done without any lectures, so they didn't participate in the lectures. But this was the first great sign for me that it basically works. So there are students that have the capability to simply use the material without any additional support. But of course, what we see now, we have, for example, if you see what the most effort is for the business projects. And here we have a range between about 6 hours for a very good student with a less complicated project, and it raises up to 20 hours for a student with a more complicated project. But this is also sometimes a mix. We have students with different prerequisites. There are some students who are already very familiar with statistics, and this is quite easy. For others, it's very complicated to get the ideas of a hypothesis, of testing hypotheses. So what we of course also monitor, not only the performance of our videos, but also of course the support effort we do, and we need to support our students. And we do this also, we also monitor the support not only for the direct support of the project, but additionally also for the management team. So you might easily can imagine that we have different sources of inquiries about the course itself, about its organization, about certification, about career and other things. And they post it in the discussion board. We get emails, we have them in our social media. And we also experience, hey, lots of these questions are already answered. And we, of course, answer them again, but we know this is a waste. So we try also to monitor which questions do we receive, which we already answered, and which are new, and how often do we need to forward certain inquiries so that it reaches the final addressee. So this is also another important aspect to monitor and to improve our project. Basically, it's the question, the success question is, does the participant successfully complete the project? And this can be clearly measured. So the application leads typically to a project success. It's my responsibility to declare this project is suitable, basically suitable. Then the student starts, and if the student will not be successful at the end of the project, it would be my fault, basically not the fault of the student. So we of course monitor and go back also if we see we missed something. So the monitoring of the performance is within the process. 5 review steps after each phase, feedback, please do it again. These are certain aspects you missed. And here we can, of course, see big differences in the competence and, most important, in the motivation. So some students are, very few are not motivated, and they make the most effort. So you can easily see they didn't watch the videos, and they didn't look into the book. They do not complete the task. They just start, and this is immediately recognizable.
Yeah, for sure. A lot of work, an impressive work, but there are a lot of congratulations from the chat, also from Mati Koivisto, that appreciate a lot the clear structure of the Yellow Belt education. So also
Thank
my
you.
appreciation for my side. Thank you very much, Dr. Reiner Hutwelker, for your presentation. So
Maria, thank you so much.
thanks to you.